Guys, welcome to today's class. Today we're going to be going over some counting techniques, reviewing and practicing other counting techniques we already went over. Now let's start with problem 22. How many positive three-digit integers are there such that each digit is an odd number less than 8? Well, how many odd numbers are less than 8? There are 4, namely 1, 3, 5, and 7. Notice that we want each digit to be an odd number that's less than 8. It satisfies the requirement. So each of the three digits have 4 choices for each. So there's 4 choices on the first one, 4 choices for the second, and 4 choices for the third. Gives you a total of 64, or B. Right? Now let's move on to problem 23. Jesse finds that by selecting from the different combinations of the jackets, pants, and shirts that he owns, he can create up to 150 different outfits, each consisting of one jacket, one pair of pants, and one shirt. If he owns 3 jackets and 5 shirts, how many pairs of pants does Jesse own? Let's let the number of pants Jesse owns be P. Now we know that the number of jackets and shirts he has is 3 and 5, respectively. Well, the number of total ways to make different outfits is the number of jackets times the number of pants and number of shirts, because we want to find all possible combinations of jacket, pants, shirt. For example, we are going to have a red jacket, blue pant, and a yellow shirt. This is an example. The colors are not said in this, but we'll take this as an example. So in this case, there are 3 times 5 times P possible ways, or which is equal to, and this should be equal to 150. His 3 times 5 times P is the total number of outcomes that he can have, consisting of one jacket, one pant, and one shirt. Well, this is equal to 150. Solving gives you P equals 10, or E. Right? Now let's move on to problem 24. A circle not drawn passes through a point A in the figure above. What could be the total number of points of intersection of this circle and ABC? So notice that ABC, this point goes through A. Well, we can just test out all the guess and check, or use the process of elimination. In this case, let A, B, C. To get 1, we can just draw a circle like this. Right? How do we get 2 then? Well, one way to do it is to draw it like this, where A and B is a chord. Now, how do we get 3? 3 is also achievable, but how do we do it? How do we accomplish it? We can do this. Hmm. Let's see. We can actually just do this. Because the angles are different in each triangle, and it's pretty much possible to do this. We can just do this. It's pretty much possible to do it. Another no construction. Another construction is like this. Oops. That's one way. We can do it on the inside where it's tangent to all 3 sides. And we call this circle an in circle. Now, how do we get 4? 4 is also pretty simple. You can draw it like this. And 5 is also pretty much simple. You can draw like this. You have 1, 2, 3, 4, 5. Alright? So you do V, all of them work, so E is the answer. Now let's move to problem 25. 3 girls and 4 boys are to be seated in a row containing 7 chairs. The chairs at both ends of the row must be occupied by girls. How many different ways can the chairs be seated? Notice that people are distinct, alright? We're not gonna make, oh, there's a Bob here and there's another Bob and they're the exact same thing. We're gonna have probably a girl, Charlie, Alexis, and someone else, probably Brittany. These are distinct people. Alright? So now we know that every person is distinct in this ordering. Now at the end, how many ways are there to put two girls in each spot? Well, this person has three choices, and the other end it has two choices left, no matter what we do. So, example, as we talked about, we have people, the girls Alex, Alexis, Brittany, and Charlie. We can put Charlie over here. We can place Charlie here, and then we can place Brittany here, or we can maybe place Alexis, Charlie. Well, if we find all of those, find the total number of ways to arrange it, that's going to be come out to 6, or 3 times 2. Now, there's not really much left that we need to think about. Because we have 5 people left after we remove the 2 girls. And we have know that there's 5 factorial ways. There's no restrictions on how to place them. So there's a total of 5 factorial ways, or 120 possible ways to order them. Add on that multiple of 6. Yeah, 120 times 6 is 720. Or B. Right? Now let's move on to problem 26. How can 3-digit natural numbers are there up to form H to U where H is greater than T is greater than U? What the? Alright. So basically, how can 3-digit natural numbers where H is greater than T is greater than U? There is indeed a formula. The formula is if we have an n-digit number, preferably less than 10, because it really only can be 98765432110. This n-digit number of 10 choose n. How many possible ways are to is this is equal to 10 choose n? Basically, how many possible ways are there to order it? From greatest to least, strictly decreasing. That is the number of ways. If the number digits, how many if someone asked you a question and they said, how many possible ways are there to write a how many possible ways are there to write a 2-digit number where the digits are strictly decreasing? The answer is just 10 choose 2. Or in general 10 choose n for n from 1 to 10, because 0 cannot happen. From 1 to 10, where n is the number of digits. This case, we just plug it in. We have n equals 3 in this case. Well, 10 choose 3 is just 120. So the answer is A. Now let's move on to here. Example 28. How many ways are there? May we write the number 9 as a sum of 2 positive integer commands? Summoned. Here, order counts. Right? How do we approach this? We talked about last class, stars and bars. What is stars and bars? Stars and bars is basically what it says, stars and bars. The problem first came up when people use it when counting sticks, stones, stars, and bars. We're trying to find the ways to erase these. Now, how do we do it? For example, we have 5 objects with 3 bars. Well, the stars and bars is where we use it here. 5 objects, and we're gonna find how many each person or each someone gets, and you have to find the ways to arrange it. Like this is one way to arrange it. This is one way to arrange it, and there's many other ways. That's what the stars and bars purpose. Another stars and bars purpose is to find a number of solutions to a bunch of variable equation. For example, we can write an equation here. How many ways to write number 9 with the sum of 3 positive integers? Well, let the positive integer be x1 plus x2 plus x3. This is equal to 9. Now, stars and bars for positive integers only. If each variable must be greater than or equal to 1, it tells us if there are n, if n is the total, and there are integers, or I should say variables, then the total number of ways is equal to n minus 1 choose r minus 1. Now we can just plug in the values. Well, there's r is 3, n is 9. So if we plug it in, we get 9 minus 1, choose 3 minus 1, or 8, choose 2. This gives you a total answer of 28, or E. Now let's move on to theorem 5. This is basically an extended because we have now non-negative integer solutions. Now, there's a way to use this formula right over here, this formula here, to derive it to here. How do we do this? Well, let there be y1 plus y2 plus dot 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 plus yn. Ignore the problem for now. We're gonna return to this problem later. Alright. Get to yn. This is equal to n. Oh, this should be yr, my bad. How do we do this? Now notice that these are not necessarily positive. But how do we make sure that these integers, or the variables, are positive integers, strictly, not 0? Well, to get from 0 to a positive integer, you can just add 1. In this case, we're just going to also add 1. Alright, we're going to write the same exact sum. y1 plus y2 plus dot 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 plus yn, alright, r I mean, plus r. We added 1 to each. Another way to, let me write it much better so you can see what we do. We do y1 plus 1 plus y2 plus 1 all the way to plus dot 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 plus yr plus 1. And this should be equal to n. Now, how do we do it from there? Well, there's r total variables, and we add 1 for each one of the r variables. This gives you a total of r. We added one r times, so 1 is r, just r. So we can write this exact same sum over here and transfer it to here. Get y1 plus y2 plus dot 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 plus yr plus r equals n. Now you'll start to see where the formula comes up. Alright? Now, we know that we forgot to add r on both another side. This is just n plus r. Because we added r on one side, we must balance the equation on the other side. Now we do from y1 to yr plus r is equal to n plus r. Alright? Now from here, it's pretty simple. Since we know they're all positive integers, we can now apply stars and bars. Or the positive stars and bars, in this case. This tells you n minus 1 choose r minus 1. If n in this case is n plus r. You see this? Now the r in this case is still r. Alright? So applying this formula gives you, for non-negative integers, this gives you n plus r minus 1. Choose r minus 1. And that's how we derive the formula. But the key thing here is just to make sure you're not using the wrong formula whenever you're using the problem. Alright, for example, if it says positive, make sure you're using the positive, not the negative, because it can result in a silly mistake or incorrect answer. Right? I'm gonna write the proof off the screen and let's tackle this problem. Okay, now we have three friends have a total of six identical pencils. In how many ways can this happen? Well, we talked about before. If the total is, we can write this as an equation. It's pretty simple. It's just say the friends are f1 for a friend, f1 plus f2 plus f3 is equal to 6. Now, they do not say that it has to be positive, so it can be non-negative. Obviously, they're not going to be negative because that's basically impossible. You can have negative pencil. Now, in this case, it's just f1 plus f2 plus f3, which is 6. This is pretty simple from there. So this is f1 plus f2 f3 equals 6. We just apply our formula. There's three total integers, or 3 is r, and 6 is n. Applying this formula gives you 6 plus 3 minus 1, choose 3 minus 1. And this gives you a total of 28. Alright, now let's move on to problem 25. The number of ways to walk from one corner to another corner of an m by n grid can be calculated by the following formula. N is equal to m plus n, choose n, where m is the number of rows and n is the number of columns. Example 25. How many ways are there to get A and B if you can only go north or west? By saying that, they're just saying you are not allowed to backtrack. Okay, you can't just go forward and then okay, I'm gonna turn back. You cannot do that because you can make it probably a whole more pass. Like I could go over it. Like for example, I'll write an example. I can go from here, and go back, and then here, and waste a lot of time. And we don't want that. We can want a direct pass. Now now this formula is very key. It's a very important. I cannot emphasize how important it is in many path counting problems. In most of your AMC 8, AMC 10 journey, AMY journey, maybe in the AMY journey, you'll find a bunch of these problems in the past questions and the current questions and the future questions. This is why memorizing this formula was very important. And how do we derive this? Well, notice that we can write, let's take this example. We have 4 and 2. This is pretty simple. I bet you can draw everything, but we want to prove, okay? Well, let's think about this. We have these segments, right? We have 4 going right and 2 up. Let's look at here. 4 right. This is a total of 4, and this right over here is a total of 2. Now, we can look at this. We can basically look at this as an arrangement of 4 rights and 2 ups. You see where I'm going? We can let R to be each one that would go to right. And then there's the U be up because we can only take no backtracking. We can only go 4. In this case, we have 4 R's and 2 U's. Do you see where I'm going? We can do this. We can arrange these. Like, for example, I can do R, U, U, R, R, R. Now, what does this path look like? This path looks like this. R, U, U, R, R, R. Is that path over here. And then notice that we talked about last uh a couple of lessons ago, like 2, 3 lessons ago, somewhere there. We talked about how to order letters. You see them as letters, and if there's duplicates, you find the number of duplicates, including the original one. In this case, there's 4. That'll be the formula should be if we have in this case. We find each letter and we find how many letters are there in each. Okay, so the total number of letters is 6 factorial in this case. And how many letters for each one? The first one has 4 factorial, that's 4 factorial. And the second one has 2 factorial, so 2 factorial. Now, multiplying this all out, this gives you 24 times 2 is 48 in the bottom. You get 720. So basically from there, you get 15. How is another way? What is it? What if we apply this formula, n plus n choose n? But wait a second. We know that this is n plus n choose n. How? This is just 4 plus 2 factorial divided by 4 factorial times 2 factorial. Which from there you can find that 4, we can get this from 4 plus 2, choose 2. This works for every possible grid path count for the other ones. Like we can have 120 for the right and 230 for the ups, or we can reverse as 230 down and 120 to the left. No matter what the direction is, it's still gonna be the width times the length added up. Choose the length or the width. So that's how you get the formula we have, or n equals n plus n choose n. Alright? Now let's tackle this question. Using the same exact logic we use, we notice that, first we gotta notice that C is literally only one way. There's only one way. You have to go through this 100%. So we can think about this like this. Well, we can connect, first do the number of paths from A to C, and then multiply that by the number of paths from C and B. Right? Why does that make sense? Because if I do A and C like this, there are many ways I can do from C to B, like this. So for each choice in A, there's a bunch of choices for C to B, right? So if we just multiply the number of paths from A to C multiplied by C to B, we get all possible situations. That's pretty simple from there. Remember that now we can just apply the formula. We talked about right before with the proof that number of paths with the 4 as the width and 2 as the length, or 2 as the length, 4 as the width. They're really just the same thing, just rotated. And they still give you the same number of paths. This is just 4 plus 2, choose 2, or remember, we calculated it, it's 15, times, this case, the length is just 3, so it's just be 3 times plus 2, choose 2, or 10. This is 15 times 10, or 150, or D. Alright, now let's move on to how many rectangles. For a rectangular grid with n vertical lines and n horizontal lines, total upper rectangles can be counted as n equals n choose n times n choose 2. Make sure you're reading this. Wait, first let's find the proof. How do we get this? For example, let's take this. This is a picture right up here. There's a picture. This is gonna help us. Why is it true? Well, how do we make a rectangle or a square? How do we do this? Well, this is just telling you, this formula, right over here, this formula. It's just telling you this. If we have n horizontal, in this case, there's 4, and vertical and n horizontal. If we choose a pair of n vertical lines and a pair of n vertical lines, we can make a rectangle. This is basically what it's saying. And the total weight is just a total number of vertical lines, choose 2, and n choose 2. Well, why is this true? Let's look at your average rectangle, alright? How do we make a rectangle? There's 4 lines. 2 are parallel, and the other 2 are parallel. Right? Now, this is what makes it interesting. From here, from this diagram, represented as M and N, we can choose any 2, right? We choose these 2. Okay? Let me draw this in yellow. Say we choose these 2. Now we can see that there's a total of N choose 2 choices. N choose 2 ways. Why? And how? Because let's start on pink. We can choose this length and this length. And since we find the intersection, we cut off extra parts. So we cut off this part and get this part and we get this rectangle. Just by choosing the vertical angle. Alright. Now we can repeat this experiment with random lines. Like this, for example. I'll draw this in yellow. I just use a pencil. This pencil is probably better. This case we can draw this blue line. And this blue line over here. And what do we get from that? I'm going to use red. Where's the green place it? We can make another rectangle. How do we do this? Find one line. That's we have find one line and find the other line. We have total of two choices of choosing which pair of lines we add next. In this case, we're gonna do this and this. That just gives you a 2x2 rectangle, and that's a distinct rectangle, alright? And that's how we do it. And this is how we prove the formula. You basically choose two pairs of horizontal lines and two pairs of vertical lines. These will always form a rectangle because they're perpendicular and they're each parallel. Alright, so now we know that how do we get these? Now let's try this problem. Consider the figure shown below. How many rectangles are there? We just apply the formula. There's a total of 5 vertical lines, 5 choose 2, and 4, and this is 4 horizontal. Or 5 choose 2 times 4 choose 2. This just gives you 6 times 10 or 60, or B. Now let's move on to example 28. How many three-digit increasing numbers are there? Now this is different from the decreasing. The increasing is obviously you can't have 0 as the first digit. So from there, there's only 9 possible digits we can start. And it's just a 9 choose n. Right? This is also a really good formula, just like decreasing. You should memorize it. But first, as it's always important to remember how to get to there. You can prove it by yourself. I think it's pretty simple. I won't prove it this class. Maybe later, but you can search the proof up. It's pretty cool. As with 10 choose n, the decreasing. So let's start. There's 3-digit increasing numbers are there. Well, any 3 in this case. You just plug it in. We get 9 choose 3. You use the formula. We get 9 times 9 factorial. By 3 factorial times 6 factorial. Is you can do 9 times 8 times 7 divided by 6. Is you can do 84 or C. Right? Digit following numbers, remember the formula, 10 choose n. This case, plug in n, we get an answer to be 120. Like the last one. Alright. That's it for today's lesson. I hope you guys have a wonderful day, and I'll see you next week. Bye.